speed. So let's do another one of those. Let's say, I like the example yesterday. Let's try thinking of who wants to be in the example this time, not you, Justice. Colin. Colin is, what does Colin do? Colin is riding a pony across a river. Sure, this is what you do.
He's going to get drinking if he's ready.
The river is 13 meters wide. It's a good river. The river is 13 meters wide, and it takes Colton 100, no, let's do it in minutes, 2.5 minutes to cross the river, that's implied. Find his speed in meters per second. There are a couple different ways that we can think about the beginning of this one. We're probably only going to have time for this. If I'm right about the bell, then we're going to have a couple minutes to do this one, and then you'll be dismissed. If I'm not, then we will do this one and then continue on with our notes, okay? So we'll just see what happens here. But what's the main difference between this one and the notes that we took yesterday? Yeah, right.
You have to convert them into
You're going to have to convert something. So you have two choices. You get a choice, just like you could choose between Italian dunkers or, I don't even know what the second thing was. I don't think you can choose that.
You can't choose two hot meals.
Yeah. I don't even know what the second choice was because I didn't ask anyone. I feel bad now.
I know.
But just like you could have chosen between chicken nuggets and chef salad, you can now choose. What are the two choices going to be? Either you can do what or what, do you guess?
Convert or what?
No, you have to convert either way. But you can choose to either convert the 2.5 minutes to seconds, or you can calculate it in meters per minute and then convert that whole quantity to meters per second. Let me say it again. You can either convert the given 2.5 minutes to seconds, or you can calculate the speed in meters per minute and then convert that to meters per second. Which would you prefer? Ashley, which would you prefer?
Minutes.
Does anyone have a preference?
No.
Count.
Rhett says he would like to convert before. Do you agree with that, Ashley?
Yeah.
Let's just do that one then. So we're going to start with the conversion. We're going to start by converting 2.5 minutes. We're going to go from minutes to seconds. In 1 minute, there are 60 seconds. So 2.5 times 60 is 150 seconds. Now that we have our time in seconds, what should we do next, now that we've done our conversion? Yeah, well, be careful, because what should we really do next?
Multiply.
No, be careful, because what should we really do next?
What we
I'm still trying to find what?
Oh, you already multiplied. Never mind that.
Still trying to find
Your speed.
speed. So what should I do if I'm trying to find speed?
Be careful.
Yes, be careful specifically how. You know, we talked about this repeatedly. What should I do when I'm trying to solve a problem that has an equation? What should I do first?
Convert. I don't know.
We already converted.
Write down the steps.
No, not right on the steps. Write down the
Unit.
Equation.
Yeah, No, not yet. No.
What in
I feel like I've crossed over into the twilight zone. The answer is we should write down the equation. We've done this before. We did this yesterday. We've done this all year long. I mean, the year's only 5 weeks long, but still. No, first we just write down the equation. We don't manipulate yet. So the equation is speed equals distance over time. You did not. You said write down the steps, which is not what we did. Speed equals distance divided by time. So we write down the raw equation. S equals d over t. Then we think, do I need to manipulate this? Equation manipulation station 1 internation. Do I need to manipulate this? Well, this is set up to solve for what quantity?
Distance over time.
No, the quantity it's solving for is speed. Am I trying to solve for speed?
Yeah.
Would you all agree? Yes, I'm trying to solve for speed. This equation is already solving for speed, so do I need to manipulate? No. Okay, next step then is
Put in your
with
units.
with units. So what can I put in for d?
Your distance.
Which is?
2.5 meters. No,
It is
13.
13 meters over time, which is
2.5.
150 seconds. We've already converted that to
Okay,
seconds.
yeah, go ahead.
Okay. Now, we do what?
you
Solve.
divide
Solve.
by
solve, and we remember the answer. So first we divide 13 by 150. Calculator boy.
Calculator boy.
Okay, just
say,
as a
Calculator man.
Thank you, Justice. That's very
I'm
flattering.
calculator man now.
Yes.
Casey doesn't want to be calculator man.
Just please let him do it and be quiet.
0.1.
0.1. Now, that's the number, and then in the
And
same way that
over S.
13 divided by 150 is about 0.1. It's not quite. Meters divided by seconds is as Paige, or as Cyrus says, meters per second. Meters per second. The bell is not ringing at 8:34. One thing I know is the bell is not ringing at 8:34 because it is now 8:35. So,
Why is it ring rise, he says?
yeah, it would be, that would be pretty par for the course. So when you have a problem like this that requires conversion, let's do it the other way now too. So instead of converting first, which is what we did, instead of how did I know to convert this to seconds?
I don't know.
How what about this problem told me to convert this to seconds?
Meters per second.
Yeah, because the answer was supposed to be in meters per second. The other way we can do this is first write our equation, speed equals distance divided by time. Then substitute, speed equals 13 meters over 2.5 minutes. Speed equals, do this one now, solve. You might just keep the calculator out because we're going to be doing this.
Wait, so what do I do? 13 divided by...
Mr. Keith,
Sorry to interrupt. Are we not doing MTS?
the bell didn't ring.
That's what I'm saying.
Yeah.
We also don't have finished maps, so how would we do it?
Better? Okay, here we go. So now, Justice has solved 13 meters divided by 2.5 minutes, which is
5.2
5.2 what though now?
meters per second.
No?
Over minutes.
Meters per minute. Are these two things the same number? Be very careful before you answer. Are they the same number?
No.
No. Are they the same answer though?
Yes.
Yes, they are. They just are in different units. So now what do we need to do? If we have something that's the same this, but we need to change the units, what process do we do if we have the right answer but it's in the wrong units? Conversion. So we have 5.2 meters per 1 minute, converting minutes to seconds, and in every 1 minute there are 60 seconds. This will give us, what's 5.2 divided by 60, Justice? Keep out the calculator. Remember when I said
0.1, right?
It should be
0.1
What though? Minutes drop out, we're left with meters
Per second.
per second. See, they're the same dad blame answer. It just doesn't matter whether we convert our given or convert the answer. I'm going to say that again because I'm pretty sure not everyone, even some of the people that usually listen, weren't listening. I'm going to say it again. It doesn't matter whether we convert the given so that it'll work out at the end, or if we find the answer and then convert that. Either way is fine. But in both cases, y'all have to do a unit conversion. And if you can't do a unit conversion because you didn't put in the work to learn about unit conversions, then the whole rest of the year is like a nightmare, like a nightmare where you're in a toilet full of lava and you're being flushed down. You have to. Exactly. You have to be able to do unit conversions. There are two vocabulary words that relate to this concept, and you should have these in your vocab, but I'm going to briefly mention them. They are average speed and instantaneous speed. The difference between those two things, is anyone listening to me?
Yes.
You have these in your vocab, so you don't need to necessarily write them down in your notes because you have them in your vocab, don't you?
Yep.
Raise your hand if you have these two things in your vocabulary.
Most likely.
The boy right
You do, yeah? Oh, good. Okay. The average speed is total distance divided by total time, whereas instantaneous speed is the speed at a given instant. You might find, if we say it took, from the time that I leave my house until I get to the place I'm going in Shatter, it might take me about 35 minutes. Still 22 miles, but it might take me 35 minutes. Let's find out what my average speed was real quick. What's my equation?
64 miles an hour.
That's not an equation. What's my equation?
So that's the answer.
S equals d over t. Speed equals my distance. My distance was 22 miles. My time was 34 minutes. Speed equals.
Hey, Joe, calculator man.
Calculator.
I think we
We're
should
going
elect.
to miles per hour, right?
We'll have to convert.
22 divided by 34 equals 0.6.
0.6 what?
Minutes.
This is not just for justice. What is 0.6?
Miles per minute.
Miles per minute.
And then
Okay,
we have to
now we convert 0.6 miles over 1 minute. I'm going to convert from minutes to hours.
Oh,
And in 1 hour there are 60 minutes.
no way I just got it.
Oh, calculator.
Should say 36.
Oh,
Miles per hour.
yeah, I knew that.
No way you're going.
Justice is right. There's no way at any point when I'm on the highway, I'm not going
That was
36
actually-
miles per hour.
It takes all like 30.
Exactly. So the average speed, even if most of the way there, my instantaneous speed, I'm on the highway, my instantaneous speed is 65 miles per hour. This also takes into consideration all the stops and turns, and I can't go 65 miles. I don't scooch out of my driveway at 65 miles an hour and then blast down the street 65 miles an hour, slowing every stop sign. So my average speed becomes a lot slower, doesn't it? You see what I mean? So average speed is total distance divided by total time, whereas my instantaneous speed is just how fast I'm going in that instant. If I'm stopped at a stop sign on the corner of Annan Street and 3rd Street, my instantaneous speed is what?
0.
0. You don't even need a unit, it's just 0. 0 everything. When I'm coasting on the highway going down one of the hills, my instantaneous speed might be 70 miles an hour. But that doesn't mean that my average speed is 70 miles an hour. Okay?
That's dope.
Your book then differentiates between these two things, and we're going to talk about this kind of at length, and then we'll go. We need to talk about, and write this down please, speed versus velocity. They are different concepts. They're both vocab words. You should have the definition for both, but I'm going to make it a little bit more specific, hopefully in your brain, and hopefully you can pass this test. So a speed, as we already discussed, speed equals distance divided by time. A velocity is a speed in a certain direction. What's the difference between these two things?
One shows direction.
One shows direction. This is what we call a vector quantity, and this is what we call a scalar quantity.
Vector. He wants to flash.
Vector quantities all have both magnitude. What's magnitude mean?
I have no idea.
Can anyone guess what magnitude means?
Magnitude.
Just guess.
Is like
Big.
Bigness.
Magma.
It's bigness actually. It's related to the Greek. The Latin word magnus means big. You know about guns? A Magnum cartridge is a bigger version of the same size cartridge. It's got more powder. It has a heavier slug. What's another word where we use? Oh, magnify means to make great. A magnifying glass makes something big. Magnitude is the bigness of a quantity. Vector has both magnitude, bigness, and direction. Scalar quantities have only,
Direction.
no,
Speed. Time.
magnitude.
only magnitude, only bigness. So let's think of a few little examples here. What are some quantities that probably have only, a bigness, only have a magnitude?
Gallons.
Volume, yeah, volume. I'm thinking of quantities, you're thinking of units. But volume is a scalar quantity. It doesn't make any sense to say that this is 1 gallon down. That doesn't mean anything. What are some of the things that only have magnitude, not direction? Volume does. What else? Mass, yeah, mass. What are some things that have a direction? What are some vector quantities that have those?
Speed.
No, speed
Oh, yeah,
specifically says a scalar quantity.
Car.
Car's not a
That's
quantity.
an object.
Miles.
Miles are a unit for distance, and distance, really, actually, interestingly, distance, let me think of how this is. Distance is a vector quantity, but displacement is a scalar quantity. We talked about distance and displacement yesterday. But I'm thinking of things like force. It does make a difference if I push my podium here. If I push it up, it's different than if I push it left, right? Force has a direction. We already said the velocity has a direction. Acceleration, we'll talk more about this in the next.
Pulling's a lot easier than pushing.
Thank you, Cyrus. Very astute. The acceleration, we'll talk about this in the next section, but acceleration has a direction. Now listen to this. Now hear this. It says, I'm going to read this to you. You need to write something of this down in your own words. Ready? Because the first word is because, you don't have to write that down. But because velocity depends on direction as well as speed, we just talked about that. Because velocity depends on direction as well as speed, the velocity of an object can change even if the object's speed remains constant. So how could velocity change even if the speed is constant? Because velocity depends on direction as well as speed, the velocity of an object can change even if the speed is constant. Velocity can change, this is what I would write down, velocity can change even if speed stays the same. How? What could be changing about it? It's on page 44, Alexine. What could be changing about it even if the speed stays the same?
An outside force, maybe? Like
The force would have to change, but that's not what I'm getting at.
motion.
Specifically, what part of the motion? Even if the speed stays the same, what might be changing about it that makes the velocity change? Direction. So I think about that curve outside of town there. When I'm going around that curve, even if my speed is 55 miles an hour and it stays that way, my velocity still changes. Don't leave yet, and don't put your notebook away because you have an assignment which is page 46, 1 through 7.
Got it, dog.
I will check to see that you have this written down as you leave. Page 46, 1 through 7.